All right. Well, in that case, this is a good segue to move on to our next speaker. So let me just stop my sharing and I will pull up his bio. All right. So Michael is currently the global head of security operations and researcher enablement at BugCrowd. He's an ex-pen tester and a builder of open source, and he's going to be talking to us today about using Interlace, which looks like an awesome framework for developing applications. Take it away, Michael.
Yeah, so I wanted to do this talk because I built this tool, as you build most tools, out of something I needed myself when I was a pen tester, but it's very difficult to explain on a README file, and it's very difficult for me to explain the benefits quickly. So I thought the best way to do this is to do a 10-minute quick live demo of what it is. The short explanation, which, as I said, hard to explain, is that when I was a pen tester, there's a lot of stuff that you have to run on every engagement. So SSL scan, NICTO, Nmap, a lot of files that you want to store so that you can refer back to them later, and coverage points. And if you get to an external engagement, you get the added problem of I've now got 60 hosts, 70 hosts, however many you've got, and I need to get data for all of them. And so you can solve that problem with Bash, you can solve that problem with parallels, but the frustration came for me when I was on site and I wanted to adjust that quickly, or even when I was remote and I wanted to quickly expand on that, or when I was working on bug bounty programs, I wanted to create something and run it at scale quickly. I'd be messing around in Bash and it was never a quick exercise. So the reason I made Interlace is to try and make that a quicker thing. To kind of jump right into that, Interlace, if you pass it a target or a target list, it creates variables off what you pass it. So I can say SSL scan the target that I've provided, and then I can also say, let's say test.text, doing things live, it's horrible. Target.text, and it'll give me SSL scan. So everything within the quotes here for the command will run, and the variables will get replaced. So I can do that, and it'll create a thread. So where this gets really interesting is that it can create threads for multiple commands. So I'll let that run, and there we go. Cool. So you can see it's run T, so we could see the results as we went, or we could have just swallowed it out to a file. And we've got our target name here with the SSL scan results, which is great. So let's say you just wanted the results, you didn't want all the garbage that came up the top. You can give it silent mode, and it'll get rid of all the commands. And then the other thing, the bar at the bottom, you can pass sober to it, and it'll cut out the bar, and it'll just give you the results back, which didn't run that time, but that's great. Where this gets interesting is, let's say you wanted to run it. Sorry, now it's running. There we go. Live demos. This target command supports your target. It supports CIDR ranges. It supports glob. So glob being that like 192.168.0.1 to 255, for example. So it supports all ranges of notation. If there's a notation file that we've missed, you can raise an issue on the repository and we'll add it. But you can also pass it a list of targets. So let's say, and where this came from, I had a client pass me a combination of glob and CIDR ranges on an external engagement. I wanted to quickly run it over everything. So we can say targets.txt file, we'll test bugcrowd.com and Kiddingo.io. And we can now replace our T command with a command list and say for every target.txt, we're going to run the command SSL scan over the target, and we'll T it so we get the file format of target SSL scan.txt. And so what it does is it runs for each of the assets in the targets list or the CIDR range, and it spins a thread up for each of them. So by default, it'll run 10 threads, but you can run more. So it means both of those SSL scans have now run at the same time, and I get them back much quicker. So if I was running over a large CIDR range, then I can just throw that in and forget about it, and it'll manage it for me. But then it gets a little bit more interesting because we can say, well, I want to create a directory before I put everything in that. So we can say commands.txt and go -P, I think it is. I hate that it's, yep, -P. So we can say for the target in a scans folder, and we'll write target SSL scan.txt. And I'll just go new line so you can see that because of the way my Vim's set up. And then we'll run SSL scan -target T. I should have actually used vim commands there. Anyway, t dot slash, and bearing in mind, there is obviously better ways to write this. I'm doing this for the sake of example, but you could use variables if you wanted to. And that shouldn't be there. Live demos, man, always.
Look, I sacrificed that rum to make sure it would not go terribly wrong.
No, that's so basically what this is going to do, it's going to make a directory, then run SSL scan. But the problem is, because this is multi-threaded, it'll start a thread for each command in the file for each target in the file. So we've added this ability into Interlace. So Prodigy SML and I built this together. I think you would have seen his name come up in the banner there. We came up with this concept of blockers. So what a blocker will do, it'll say, run everything above this command before you run the command below it. And that way it ensures that the directory is built before the SSL scan runs, but still manages the threads appropriately. So it'll still go over our target list, but we can now say, use the commands list. So it'll multi-thread the targets and it'll multi-thread the commands, but it'll make sure it runs them in the right order because of that blocker. So it'll now spin up the 4 commands, because 2 commands per command list, 2 targets. So we've got 4 commands. It could be 600-700 of this. It could be 6,000-7,000 of this. Some people have used this for bug bounties and run it at ridiculous scales. And then you can see now for each target, we've got a directory with our results, except I wrote targets, not target. So it didn't spit out properly, but more on muchness. Whoa. So if we wanted to, we could also say, that command, let's also then run nicto for nmap for it. So we'll just say nmap target, and we'll fix this while we're here, because say just 1 port for speed reasons, and we'll go output all to target, scans, target, and it'll do the nmap annotation around that. And so now, I should have control that. There we go. Cool. So it'll now run nmap as well. So for every target that we pass it's going to make a directory. It's going to run SSL scan and nmap. So we've now got a file for all of the must run each time we do an engagement. And you can see with the multi-threading, it runs it quite quick. So we can now go, you can see we've got all of our nmap output as well as our SSL scan and our junk SSL scan output from before. So you get this, sequential path of being able to quickly map out your results for an engagement. So we've got blockers, which allows us to block things. It's not the most effective thing for multi-threading, because now, before these 2 threads start, the threads above it must execute, which isn't a big problem for making of a directory, but it can be a problem otherwise. So to come around that, if we rewrite this, there's a secondary concept called block. And so what a block does is for everything in the block, and so it's descriptive by the block, and then after the colon you can name it, so you can keep them organized, you can have separated blocks, and you can embed them as well. But the way a block works is that they can start separated threads. So we'll create 2 blocks here, we'll create another one for SSL scan, right? So I need to get better at typing. So now if we had 2 separate threads we wanted to run, we can, if we wanted to, run multiple nmap commands in here. Whoa. Yeah, I'll just type it. Sure. Cool. I wrote that one wrong. So that one's done. We'll say make directory, and now we might want to organize this even further. So we might say target, scans, and we'll just say, look, everything there, put it in an nmap directory. And for here, we might say, okay, well, we want to put everything here because we might want to run test SSL as well as SSL scan and start to get organized, which I won't do just for time for execution, but we could, if we wanted to, add as many commands here as we wanted. So I really have to fix that. Okay. / target. Actually, so we should call that SSL scan.text, and we'll leave that because nmap's easy to identify. So cool. So now what we've got is 2 blocks. So it'll make a directory for nmap, it'll run nmap, and if we wanted to run, you know, an nmap UDP scan or something else, we can run it underneath. And because it's multi-threaded, if we had a quick nmap scan and then a long nmap scan, it'll spin both threads up. So you'll get your quick results back, and you could then, whilst the larger scan is running, start to analyze those by, so you could name, if you wanted to, and this is a concept you would see in Reconnoiter if you've ever used it, we could say this is the quick, and we won't add it for this being a demo, but we could say target to do all ports and then output that as, you know, and I'll just, for the sake of example, cut it short, we could output it as all. So these two threads will run in parallel because they're in a block, but the way that Interlace works, it'll make sure that they run in order. So it'll make sure the quick scan runs before the detailed scan. So you can review those results first, it'll start to run the next one, and it'll run both blocks at the same time. So whilst your nmap quick scan is running, SSL scan is running as well, depending on how many threads that you've passed it. So it allows you to get as much time effectiveness as possible out of the run, as well as start consuming the results. So being a demo, I'll quickly check. I don't think I've got a typo, but I may do. So it's going to make the directory for nmap, pass out nmap, pass it as quick. Cool. So again, we'll pass both targets. So we could even, you know, specify that comma delimiter if we wanted to, and we'll pass the command file. And so you can see now it's created multiple threads, but it is doing it in order, except I did make a typo because it, yeah, my bad. It's going well. I don't see where the typo is. That might, whoop, there we go. Cool. Nope, still got a typo. Okay. Regardless, essentially what it's going to do, a block should run in order. A blocker will mean that everything before it runs first, which might be a bug that's happening there, which is great to find out now. But it allows you to quickly create these command files and store them. So if you're a pen tester, you might have one for, okay, every time I run a web asset, I used to have a junk.il file where I had all of the stuff that you had to run for coverage to get your like SSL garbage and stuff like that into your report. And so I'd make sure I ran that at the beginning of the engagement, so I had it all stored. So when I got to reporting, I never didn't have it on hand. And then I had my findings.il, which had, you know, ran the scripts that I wanted to run and did the more impactful nmap scans I wanted to run. And that would allow me to run at the beginning of engagement, store everything. And as I dig into my threads, I've got everything organized and stored. And it's always organized and stored in the same means because it's in a commands text. I can define the folder structure as I want it here, and every engagement I run, it's going to be the same. So if I come back a year from now and I pull off file storage and I'll test, I know how it's structured. I know that I've got the data, and if it's not there, it means I didn't run the file. As opposed to, you know, if you're a pen tester and you don't do something like this, you might go, hey, I'm going to run SSL scan and I'll start to jump this into my notes and all of that. And it's very quick then to get to a point where you might run it, engagement ends, you're now running it again against an asset whilst you're out of scope, which isn't a big problem for something like SSL scan, but it could be a big problem for something like nmap. And especially if you were working on an internal and you no longer have access to everything. So the intention behind Interlace is to create, and I'll show you there's quite a lot more to this, is to create a number of variables. So we've used target here. There's also an output variable. There's a protocol variable, a whole variety of stuff, ports as well. So if you are pivoting, you can use a port pass through your command. But the intention is to allow you to support as many targets as you want, and command list to support a structured way of testing to store for the long term. And even other use cases outside of pen testing. I've used this on bug bounties where I've got standard stuff. You know, I see an ASP.NET target. I know which scripts I want to run. So I go to those scripts and I run the command file that encapsulates them all. Instead of having to write a bash script for everything, I can just quickly put together an Interlace command file. And fully owning, like, there are better ways to do this if you want to put the time in. I mean, you can use parallels, you can write bash files, you can write your own Python for it, but the intention of Interlace is to use it on the fly. So we've written a command file, you know, we're in a 10-minute slot, we've done it really quickly, and we've got long-term storage of that. So there's a lot of flexibility that comes in with that kind of intention that I think makes it a valuable tool. So on that, I will Whoa, there we go. That didn't work either. And my talk.
Thank you very much, Michael, and thank you for the ASCII version of the logo. I think we're going to be looking at whether we can put that on a t-shirt. I suspect not, just because of the fine work with the characters, but our graphic designer is hot at work looking at if she can do that. We've got some questions in the questions room, so if you've got some time, we'd love for you to be able to answer those questions as well.
Awesome.
Fantastic. Thank you very much.